Hello students, welcome to the classroom point. In our today's class, we shall discuss about the percentage purity calculations. Usually, these percentage purity calculations are very important and tricky also, and will confuse us while solving the most of the questions in the examination, competitive examinations. So let's try to understand by taking many examples in this video. We shall begin with the definition, formula, and later we shall practice some of the important questions which were asked in the previous examinations as well as in the reference textbooks. So let's begin. Percentage of purity. The definition of this percentage of purity is, it is the mass of pure substance present in 100 grams of impure substance. For example, in 100 grams of impure substance, if the pure substance is present 80 grams, then its percentage of purity is 80%. Let us convert this definition into the formula. So, percentage purity is equals to mass of pure substance upon mass of impure substance into 100. Here we have taken the mass. We can take the volume also. If you take the volume, it is the volume of the pure substance divided by volume of impure substance into 100. So let us try to solve some of the questions. So the first question here is, what is the mass of CO2 formed on heating 10 grams of 80% pure CaCO3. So this is the question given. So we need to calculate the mass of the CO2 formed on heating the 80% of the pure CaCO3. So for every question what we are going to solve in using the percentage of purity, we need to write down the balanced equation for that reaction. So here CaCO3 on heating decomposes to the CaO plus CO2. Molecular mass of the CaCO3 is 100 grams. 100 grams of CaCO3 is giving 44 grams of CO2. Here how much was used? 10 grams. 10 grams of CaCO3, if participate in the reaction, it would give 4.4 grams. But this 10 grams is not the pure substance. It is impure, means 20% impurities are there. Then let us try to apply these calculations in this formula. So percentage of purity, how much is given? 80% is given. 80 is equals to, they are asking the mass of the pure CO2 they are asking. So that mass of pure CO2 divided by mass of the CO2 formed from the impure substance. How much? 4.4 grams into 100. Then mass of CO2 formed is equals to, do the multiplication, 80 into 4.4 divided by 100. So this gives 80 into 4.4 divided by 100, it gives 3.52 grams. So this much mass of the CO2 would be formed by heating the 10 grams of 80% pure CaCO3. Let us take some question, one more question. We have many questions in this video. So the second question is, what is the mass of 70% pure CaCO3 to be taken to produce 11 grams of CO2. So the concept is similar, but here we need to calculate the mass of the reactant. So the solution for this is, again write down the balanced equation. CaCO3 on heating gives CaO plus CO2. As usually, molecular mass 100 grams of the CaCO3, because its molecular mass is 100 grams, gives 44 grams. That means 44 grams of CO2 is formed from the 100 grams of the CaCO3. Then 11 grams of the carbon dioxide would form from the how much mass of the CaCO3. So mass of CaCO3 required to create the 11 grams is, do the cross multiplication, 11 into 100 divided by 44 goes 4 times, it is equals to 25 grams is required. But this 25 grams of pure CaCO3 is required. But they are asking about which one. Mass of 70% is pure, means impure CaCO3 mass they are asking. So let us substitute this information in this formula. So percentage is given 70% and mass of the pure CaCO3 was 25. Mass of the impure CaCO3 that is to be calculated into 100. So that here mass of impure CaCO3 equals to 25 into 100 divided by 70. So let us try to do the calculation for this. 2500 divided by 70. 35.71 grams. 35.7 grams we can take like this. Let us see one more question, because you must understand one thing, that this particular formula you can understand logically by solving the many questions only. That's why this video consists of the many exemplary questions. So the next question is, how much salt cake? How much salt cake could be produced from 100 grams of 90% pure salt on heating on reaction with sulfuric acid H2SO4. So let's write down the equation for this. First of all, you should know what is salt cake. Sodium sulfate Na2SO4 is called as the salt cake. So let's write down the reaction between the salt and sulfuric acid. Salt means here NaCl on reaction with the sulfuric acid produces Na2SO4 plus 2 moles of HCl. So 2 NaCl is required. Molecular mass of NaCl is 2 into 58.5 grams. So 58.5 grams, 2 into 58.5 grams of the NaCl is producing, molecular mass of the sodium sulfate is 142 grams. Then here they are asking 100 grams of 90% pure salt can produce how much mass of the sodium sulfate. So let us take the 100 grams could produce how much. So mass of the Na2SO4 that is going to produce from which compound? Impure compound. So mass of the Na2SO4 formed from the impure compound is equals to, do the cross multiplication, 100 into 142 divided by 2 into 58.5. So this value 100 into 142 equals to divided by 2 divided by 58.5 equals to 121.36. So this is what? It is the mass of salt cake coming from the impure salt, 90%. But we want the, 100 gram salt, but actual 90% is pure salt, how much has to be calculated? So that percentage, 90% is equals to, so here mass of the salt cake that is produced from the pure salt, that has to be calculated. And if from impure salt, how much has come? 121.36 into 100. So mass of Na2SO4 that is going to produce is equals to 90 into 121.36 divided by 100. So 90 into 121.36 divided by 100 equals to 109.2. So 109.224 grams. So this much salt cake could be produced from the 100 grams of the 90% is pure salt on reaction with the sulfuric acid. So let us solve one more question. So fourth question now. How much 80% pure salt cake could be produced from 100 grams of 90% pure salt on reaction with sulfuric acid, H2SO4. Similar question, but the difference between these two is, here they are asking about the pure salt cake. But here they are asking about the impure salt cake, means product is not completely 100% is pure, it is somewhat impure compound. So let us try to solve the equation. Again, balance the equation, same equation I am going to write down here. 2 moles of NaCl gives, on reaction with the sulfuric acid, produces Na2SO4 plus 2 moles of the HCl. So here I am not doing this particular calculation, because from 100 grams of the 90% is pure salt cake, we know that how much the salt cake is going to produce, that is 109.224 grams. That means here I am directly taking that value, only 100 grams of 90% pure salt could produce how much? 109.224 grams of the Na2SO4. Now let us try to directly substitute this value in the formula. So 80% is they are asking, and here they are asking 80% is pure salt cake, that means remaining 20% is impure. So mass of the impure salt cake, that is Na2SO4, they are expecting. Now from 100 grams of 90% that were already calculated, so 109.224 grams into 100. So mass of impure, I stands for the impure here, Na2SO4 equals to 109.224 into 100 divided by 80. So it is 109.224 into 100 divided by 80 equals to 136.53. 136.53 grams of impure salt cake could be produced. That is how much impure, 20% is impure, remaining 80% is pure compound. Question number 5. So this was asked in the previous NEET examination. What mass of (95%) pure CaCO3 will be required to neutralize 50 ml of 0.5 m HCl solution. Equation also given here. CaCO3 on reaction with 2 moles of HCl gives CaCl2 plus CO2 plus H2O. So this is the question asked in the previous NEET examination. So first of all, we need to calculate what is the number of equivalents of the CaCO3 present. So here for any question, number of gram equivalents of CaCO3 is equals to number of gram equivalents of HCl. So let us calculate the number of gram equivalents of HCl because its molarity and volume is available here. So here number of gram equivalents of HCl is equals to normality into volume of the compound in the liters. But here molarity is given. So that we know that normality means molarity into basicity of the acid into volume in liters. But volume is given in the milliliters. So that we can take this one as volume in the milliliters divided by 1000. So given molarity is 0.5. Basicity of the HCl is 1 because it can release only 1 H plus N on reaction. And given volume is 50 divided by 1000. So that here you can write down the 25 into 10 power minus 3 number of gram equivalents of HCl. But here we have said already number of gram equivalents of HCl is equals number of gram equivalents of the CaCO3. So number of gram equivalents of CaCO3 also equals to 25 and 10 power minus 3. So here number of gram equivalents of CaCO3 formula weight by equivalent weight. Number of gram equivalents value here is 25 into 10 power minus 3. Weight we don't know, that it has to be calculated. Equivalent mass of the CaCO3 is 50. So weight equals to 25 into 50 into 10 power minus 3. So this value equals to 125 into 10 power minus 2 or else grams. That value equals to 1.25 grams. This is what pure CaCO3 on reaction. But they are asking how much? 95% is pure CaCO3 means mass of the impure CaCO3 they are expecting. So let us try to solve this further. 95% is given. Mass of pure CaCO3 that we know here 1.25. mass of impure CaCO3 was expecting into 100. So here mass of impure CaCO3 is equals to 1.25 into 100 divided by 95. So 125 divided by 95, it is 1.315 grams. 1.315 grams approximately equals to 1.32 grams. So like this we can solve. Here first of all we calculated the number of gram equivalents of the HCl. Then these gram equivalents we have taken the number of gram equivalents of CaCO3. Then we use this formula, then solving this format. So directly we cannot go to this question because we don't know what mass of CaCO3 is present. So let us go with another question. I shall arrange this part first. So question number 6 now. Calculate the mass of magnesium phosphate Mg3PO4 taken twice that will be formed So the question they said, assuming 100% yield, means complete reaction is taking place. From the reaction, of 15 grams of 92.5% magnesium hydroxide with an excess of H3PO4. So here they provided the information, that is molecular weight of magnesium hydroxide given as 58 and magnesium phosphate given as 262 grams. So reaction also provided 3 moles of magnesium hydroxide on reaction with H3PO4 giving Mg3PO4 taken twice plus 6H2. So this is the question given here. Let us try to solve this one. So solution here, according to the balanced equation, 3 moles of magnesium hydroxide. Magnesium hydroxide molecular mass, each magnesium hydroxide molecular mass is 58. That means 3 into 58 grams of magnesium hydroxide is reacting with magnesium phosphate. Only 1 mole of the magnesium phosphate is formed here. 1 mole magnesium phosphate molecular mass is 262 grams. Then they are asking 15 grams of magnesium hydroxide can produce how much mass of the magnesium phosphate. Remember that whatever the mass of the magnesium phosphate is coming, it is not coming from the pure magnesium phosphate. It is only 92.5% of the magnesium hydroxide. From there it is coming. So that mass of the magnesium phosphate, that is Mg3 PO4 taken twice. So here that is formed here is equals to cross multiplication 15 into 262 divided by 3 into 58. So here it is equals to 15 into 262 divided by 3 divided by 58 equals to 22.58 grams is producing. That will produce from the 15 grams completely participates, but 15 grams is not participating. In that only 92.5% is participating. So that percentage 92.5%. So here from impure compound how much is produced? 22.58, and mass of the pure compound from pure compound, that is magnesium hydroxide, expecting here is mass of magnesium phosphate Mg3 PO4 taken twice into 100. So that here cross multiplication mass of pure magnesium phosphate Mg3 PO4 taken twice is equals to, do the cross multiplication, 92.5 into 22.58 divided by 100. So that the value is equals to 92.5 into 22.58 divided by 100, 20.88 grams. 88 grams can be produced. Now let us try to solve, take one more questions, because this percentage purity calculations usually by solving one or two questions it becomes difficult for the students to understand the concept. Repeatedly if you solve more questions, then they will come to know how to apply the formula in the various conditions. Then it will be very helpful for them. So in the coming calculations we are also using the volume calculations also. So please do watch that. So seventh question here is, this is related to this question. Calculate mass of (88.5%) magnesium hydroxide needed to make 127 grams of magnesium phosphate. So here this much is given question. So already equation was written. The same equation we have write down the, here also balance the equation. 3 moles of magnesium hydroxide on reaction with the 2 moles of phosphoric acid is producing the Mg3PO4 taken twice plus 6H2O. So the given question is, mass of the impure magnesium hydroxide has to be calculated for 127 grams. So from this balanced equation, 3 into 58 grams is producing 262 grams. That means 262 grams is coming from the 3 into 58 grams of the magnesium hydroxide. Then 127 grams could be produced from how much mass of the magnesium hydroxide. So that here mass of the magnesium hydroxide required is equals to, do the cross multiplication, 127 into 3 into 58 divided by 262. So here 127 into 3 into 58 divided by 262. 84.34 grams of pure substance is required. But they're asking for the impure compound. Remaining is impurity. Only purity is 88.5%. So here 88.5 is equals to. So here pure compound, how much was there? 84.34 grams, and mass of the impure magnesium hydroxide required into 100. So here mass of impure magnesium hydroxide required equals to the cross multiplication 84.34 into 100 divided by 88.5 grams. 88.5% is given. So calculation is 84.34 into 100 divided by 88.5. That equals to 95.3 grams. So 95.3 grams of the 88.5% of the magnesium hydroxide is required to produce 127 grams of the magnesium phosphate. Let us solve some more questions. So only my request is, whenever you are watching this video, please do note down the question before I solve it. So whenever I am explaining this question or writing the question, you also write down the question, pause the video and solve on your own, because we have seen 2 or 3 questions already. This is the 7th question, 6 questions you have already seen. If you understand the concept in the first and second question itself only, then for remaining questions, you write down the question whenever I am writing the question. Then pause the video, solve the question. Afterwards, you see the solution. So that shall be an instantaneous practice for you also. So 8th question now. Calculate the percent purity of a sample of magnesium hydroxide if titration of 2.568 grams of the sample required .38 38.45 milliliters of 0.6695 molarity phosphoric acid. So similar question we have already solved using the calcium carbonate and reaction with HCl, that is I said already in 2022 question. You pause this video now and solve the question, and afterwards you watch this solution. So here solution is, whenever the complete neutralization titrations are given, you have to go for the number of gram equivalents. So that here number of gram equivalents of magnesium hydroxide is equals to number of gram equivalents of H3PO4. So in the case of the H3PO4, molarity and volume is available. Let us calculate the number of gram equivalents of the H3PO4 first. So here number of gram equivalents of H3PO4 equals to number of gram equivalents formula normality into volume in liters. Normality is not given but molarity is given, so that molarity into basicity of the acid into volume in the liters. But volume is given in the milliliters, so that let us take volume in milliliters divided by 1000, because 1 liter is equals to 1000 ml. So what is the given molarity here? 0.6695 molarity into basicity of the acid. They said titration. Titration means complete neutralization takes place. Half neutralization, 1/4 neutralization, 1/3 neutralization usually don't take place. That's why whatever the number of replaceable H plus ions are there, we have to consider all the H plus ions. H3PO4 is able to produce the 3 H plus ions. That's the reason why its basicity is equals to 3. So N value is equals to 3. Volume is equals to 38.45 divided by 1000. So let us do the calculation for this. 6695 into 3 into 38.45 equals to divided by 1000. So 0.077 is given. These mean number of gram equivalents are there. So number of gram equivalents of magnesium hydroxide MgOH taken twice is equals to weight by equivalent weight. So number of gram equivalents already here we have taken 0.077 equals to weight divided by equivalent mass. Equivalent mass of the magnesium hydroxide is molecular mass by its acidity. So molecular mass of the magnesium hydroxide here we have seen that 58. So 58 it can produce the 2OH minus ions. That's why 58 divided by 2 is equals to 29. So 29. So weight of magnesium hydroxide required equals to 29 into 0.077. So that value is equals to 29 into 0.077 is equals to 2.233 grams. So this much is required, but actually this is a pure compound required, but this is the percentage we have to calculate. So how to calculate the percentage? Percentage purity is equals to, what is the actual mass required? 2.233 grams. What is the given mass here? 2.568 grams. So here 2.233 divided by 2.568 into 100. So this calculation 2.233 into 100 divided by 2.568 equals to 86.95. So this value equals to 86.95% is approximately is equals to 87% we can consider it. So in this question, just like in the earlier questions, first we calculated the number of gram equivalents of the acid because the data from the acid is available. That's why we can calculate the number of gram equivalents of the acid easily. And these gram equivalents we made equals to the magnesium hydroxide because from the magnesium hydroxide no other data is available except this much. This is original mass, but everything is not participating. That's why they ask the percentage purity of the magnesium hydroxide. So for that purpose, we calculate what original mass of the magnesium hydroxide is participating. Then we went for the percentage calculation. Original mass participated divided by the total mass into 100. So let's see the next question. What volume of nitrogen gas is formed if 120 grams of 85% pure sodium azide decomposes. Sodium azide molecular mass is given. Molecular mass of the sodium azide NaN3 is equals to 65. So sodium azide decomposition, and you must remember that this particular compound is used in the airbags that opens in the vehicles. So whenever electric spark goes to the sodium azide, it will immediately instantaneously decompose and produce the nitrogen gas. Because of the nitrogen gas, the airbags open it. So now let us take 2 moles of NaN3 on heating, decomposes completely into its respective elements, sodium and nitrogen gas. So everything calculation is at STP. So here 2 into 65 grams of sodium azide, because 2 moles is participating. It is producing 3 moles of nitrogen gas. 1 mole of any gas at STP occupies 22.4 liters. That's why here also 3 into 22.4 liters of volume is occupied. Then here 120 grams of sodium azide if participates. It is not completely participating, only 85% of that is participating. So that 120 grams of sodium azide if participates, how much it will be produced. See here method 2 also we can apply it, because 120 grams of 85% of 120 grams, if you directly take it, you get the direct volume. But we are using this particular formula, so I am solving the question how this information can be substituted into that particular formula, and we will go for the method 2 also. So here volume of N2 that is going to produce from this particular mass is equals to 120 into 3 into 22.4 divided by 2 into 65. Here also grams cancel out. So value 120 into 3 into 22.4 divided by 2 equals to divided by 65. 62 liters. But the 62 liters is not coming originally from the 120 grams of the pure substance. It is only 85% pure. So that here 85% pure. Volume of nitrogen gas that you are expecting, and this is 62 liters of the nitrogen gas that comes from the 85%. So that here volume of the nitrogen gas is equals to 85 into 62 divided by 100. So that here 85 into 62 equals to divided by 100. So that it is equals to 52.7 liters. As I said, let us use the method 2 also, how to solve this question without using this formula in the interim method. See here, first of all, you have to calculate out of 120 grams how much is participating. Only here 85% means 120 into 85 divided by 100. That means 1 or 2 grams is participating. If you go for the method 2, then here 2 into 65 grams is producing 3 into 22.4 liters. Then here 1 or 2 grams produce how much? 1 or 2 grams means why we did the 1 or 2 grams? Because entire 120 grams is not participating. 85% of that mass is 1 or 2 grams. So 1 or 2 grams could produce how much volume of the nitrogen gas? So volume of the nitrogen gas that could be produced equals to 1 or 2 into 3 into 22.4 divided by 2 into 65. So let us try to solve this. 1 or 2 into 3 into 22.4 divided by 2 equals divided by 65 equals to 52.7 liters. So like this also we can solve the question. I hope you understand this. Let's move on to the another question. So question number 10. What volume of chlorine gas could be produced at STP if 39.8 grams of 84% pure potassium chloride reacted with excess of fluorine gas. So molecular weight of potassium chloride is given 74.5 grams. So now let us try to solve this question. First of all, we have to write down the balanced chemical equation for this one. Solution. They said potassium chloride, chlorine gas is producing after potassium chloride reacted with the fluorine gas. So take the potassium chloride, made react with the fluorine so that potassium fluoride, chlorine is replaced. Two chlorines are there, balance this so that everything is balanced. So now let us see here, 2 into 74.5 grams of potassium chloride after reaction with the fluorine is producing 1 mole of the CO2. That means 22.4 liters of the CO2 at STP. Then 39.8 grams. Method 2 you can apply it later because I had already explained that. So 39.8 grams could produce how much volume? So volume of the Cl2 that comes from the impure sample is cross multiplication 39.8 into 22.4 divided by 2 into 74.5. This value equals to 39.8 into 22.4 equals to divided by 2 equals to divided by 74.5. 5.98 liters. This 5.98 liters is coming from the impure sample. But in that only 85% is participating in the process. So that 84 is equals to, so volume from the impure sample is equals to 5.98. Volume from the pure sample that you are expecting, volume of pure Cl2 you are expecting is in this value you take in the numerator into 100. So volume of Cl2, now do the cross multiplication 84.84 into 5.98 divided by 100. Here, whatever the volume we calculated, if this completely participates, but it is not participating in the process. So it is equals to 84 into 5.98 equals to divided by 100. 5.02 liters. So this much volume of the potassium chloride on reaction will produce the chlorine gas. So let us take one more question, 11th question. X grams of 50% pure potassium chlorate KClO3 liberate 0.3 moles of oxygen on thermal decomposition. X grams of pure H2SO4 require how many grams of NaOH for complete neutralization. So molecular mass of KClO3 is given. Molecular weight of KClO3 equals to 122.5 grams per mole. So let us try to solve this question. So here two questions, two equations are there. Solution. Write down the thermal decomposition reaction for the KClO3. 2 KClO3 on heating gives 2 KCl plus 3O2. Molecular mass of KClO3 is 122.5 grams. So 2 moles participate. So 2 into 122.5 grams is producing the 3 moles of O2. They are asking 0.3 moles comes from how much? So if 0.3 moles are there, then how much is the mass of the KClO3 is participating? So mass of KClO3 that could produce on heating 0.3 moles of the oxygen is, go for the cross multiplication. So 0.3 into 2 into 122.5 divided by 3. So this value is equals to 0.3 into 2 into 122.5 equals to divided by 3. 24.5. 24.5 grams is required. But what they said here is, it is only 50% is pure. So percentage purity is only 50%. That means it is impure sample. So mass of the impure compound we have to calculate. Pure compound if participate requires 24.5 grams. So mass of impure KClO3 required into 100. So mass of impure KClO3 required equals to 24.5 divided by 50 into 100. It goes 2 times. This is equals to 49 grams. So X grams, X value is equals to 49 grams. The same X grams is participating, X grams of pure H2SO4. Means same X grams of H2SO4 reacting with NaOH, but in that reaction, how many grams of NaOH was required? That means here how many grams of H2SO4 is participating? 49 grams. So 49 grams of H2SO4 requires how many grams of the NaOH? So let's write down that reaction also. I'll write this part. So here H2SO4 on reaction with NaOH, it will produce Na2SO4 plus 2H2O. Look at this side, molecular mass of H2SO4 is 98 grams. So 98 grams means 1 mole reacts with 2 moles. 2 moles means here 2 into 40 grams is the molecular mass of the NaOH. 98 grams of sulfuric acid requires 2 into 40 grams means 80 grams of the sodium hydroxide. But how many grams of sulfuric acid is participating here? 49 grams requires how much? That means mass of NaOH required is equals to only 40 grams. So let us solve the one more question. 12th question. Thermite is a mixture of powdered aluminum and ferric oxide reacting as, so the reaction is provided here, to aluminum plus Fe2O3 gives Al2O3 plus 2Fe. The question is, if 2.44 grams of 95% aluminum reacted, how many grams of Al2O3 can be produced? So here molecular mass of Al2O3 is given as 102. So let us try to solve this question now. So let's write down the same balanced equation once again. 2 moles of aluminum on reaction with Fe2O3 produces Al2O3 plus 2 moles of iron. Aluminum atomic mass is 27. So 2 into 27 grams of aluminum on reaction with some mass of iron oxide produce 1 mole of Al2O3. Its mass is 102 grams. Then if 2.44 grams participates, 2.44 grams of aluminum participates, how much could be produced? But this is not the pure, it is still only 95%. So here mass of Al2O3 could be produced is equals to cross multiplication 2.44 grams into 102 grams divided by 2 into 27 grams. Its value is equals to 2.44 into 102 divided by 2 divided by 27. 4.6 grams. So let us see, given mass is 95% purity is there, 95 is equals to, so this is coming from the impure sample, that is 4.6 grams here, and the mass of the pure Al2O3 they are expecting into 100. So mass of Al2O3 is equals to, then go for the cross multiplication, 95 into 4.6 divided by 100, this value 95 into 4.6 divided by 100 equals to 4.37 grams. So dear students, I hope you understand this calculation. So follow this sequence and try to solve some more questions. If you have any doubt, please do write us to the classroom.gmail.com, which is displayed on the screen, and follow our social media accounts as well. Thank you one and all.